Hello guys, in this video I'm going to explain how volumes is stored and manipulated in Houdini. And I'm going to start by drawing a grid here with a set of points. And this is basically a grid with points. This is a normal geometry. And in Houdini we can use a point VOP or a wrangle or anything to change the value of these guys. So what we can do is we can take these points, and using a point VOP we can take the current position and apply a noise to them and move them in a different position. We can change the point position to be in a different location. We can also change any value alongside P. We can change color, we can add new attributes, we can create anything like that. And with points, the attributes are called attributes. Let's say P is an attribute, CD is for the color, we have velocity for V, and then N for normals, and we can create any attributes, and this is what they're called attributes. With volume, things are a little bit different. With volume, we always have a domain that we work with. So let's say this is our domain. Okay, and the volumetric data can only be represented in this domain. We cannot have data just randomly spread like we have with points. We can just throw points anywhere and they are not restricted by any domain. With volume, you always have to have a domain, which is basically a 3D grid. And inside this domain, we have what we call voxels. And what happens is each axis is divided into smaller chunks that constructs the voxels. So let's say we have 10 units here. It's going to be split every 1 unit, not this way, but basically it's going to be split in every axis, and then each one of these guys is called the voxel. Okay, the more divisions you have, the smaller the voxel is, and the more resolution you can store, the more precise your volume representation is going to be. Now let me try and draw another one. Okay, so let's say we have a sphere. We made a sphere out of volume. Okay, we see it here as density. Now, when we create data in here, there is actually voxels everywhere. This entire domain has voxels, but only voxels that are in this region, in this sphere, are filled with density. And these things, the density, for example, is in volumes is called field. It's basically attributes in the geometry. They're called these guys are called attributes. When we work on volumes, they are called field. So we have a density field, for example, and we have two types. We have a scalar, which is a float, a scalar field, and a vector field. And a vector field is basically 3 scalars. Let's say velocity, we have val.x, val.z, val.y, and val.z. And with volumes, they are called fields. And in this case, the density field has a value of 1 in this region, and then everywhere else is 0. And in order to, we can manipulate any value we want inside this domain. So we can take this entire grid here and change the value of each of these voxels to something else. We can erase completely this sphere, for example, or we can add noise to it. We can change the current value and add noise to it. We can add new values here and make the entire domain filled with noise. We can generate a noise and multiply it with this sphere, so we only have noise here. But the main difference with points, we can transform them in space without any problems. But for us to move this volume here 5 units this way, we cannot do that. We cannot move data in different in any position by treating it like points. We cannot do that. We have to do something different with volumes, and that something different is called volume sample. And what happens is, when we work with volume, when we run any operation, it's going to loop over each voxel, whether we use it or not, and then for that, it's going to sample its volume, its value, let's say the density value. It's going to sample that. And for us to move this data 5 units, we have to shift that sampling position 5 units, and then when it starts looping over, instead of this point here, for example, querying from its actual position, we can tell it to query 5 units away from its origin in this direction, and that will cause the entire sphere to shift this way. Okay, and we can do the same thing. We can shift the data in different directions using the volume sample. And let me create an example and show this in action. Okay, so I'm going to create a geometry node, and I'm going to create a box. And to convert any geometry into a volume, we can use an iso offset node. And this will take the input geometry and convert it into a volume. Now we can increase the division here, which will generate more voxels, which will make the voxel size smaller and basically give us 100 voxels in each axis. And if we middle click now, you can see we have 100 by 100 by 100. That's the domain we have. Now this field, it's a float field, but it doesn't have a name, so we're going to give it a name. I'm going to call it density. Okay, now if I middle click, see, it's very similar to the point attributes. It's called density. And now to manipulate that, we're going to use a volume VOP. And this volume VOP is going to loop over each voxel, same as if we have points, and we can change that data. We can manipulate that data. Now see here, it has an output called density, and whatever we do here, we can import the density, manipulate it, and then send it back. So I'm going to create a multiply. I'm going to create a noise. And let's multiply this density by this noise. And let's plug it back. Now see, we're changing the density value. Okay, let me increase the multiplier. And this guy is returning values between -1 and 1. And I don't want the density to be negative because we can't view that in the viewport. So I'm clamping the values between 0 and 1. And we can also clamp it between something, let's say, something like that, so we don't have empty data. And we can play with the noise. Okay, we can play with the noise. And currently, we're taking that field, changing its current value, the value of each voxel, and then exporting it back again. Now, let's say we don't have a box. Let's say we have a teapot. Let's create a teapot. Okay, and let's run the volume VOP. Now look at how the noise is only appearing where there is data. Okay, and that's because we only have density here, and we're generating noise and then multiplying it. It's not changing these values. Now, if let's say we want to move these points, we want to move the teapot from this from its current position to a different location. We cannot do that with this. We cannot do that by manipulating the volume, the density itself. We need to offset the sampling position at, and instead of having the current sampling go over each voxel, we're gonna offset the position where each voxel sample its data from. So instead of having this point here sample from that location, we're gonna tell it to sample 5 units away. And then this point here, instead of it's going to sample from this location, it's going to sample from 5 units away, and that will make this density show up here. Now let me add a volume sample. And we're going to pass in the sample position, which is P, and let's plug it back in. Okay, and for the input, we're going to set first input, and it's going to pick the first primitive, and the reason for that is because if we look here, this is number 0. It's the first one. We can also change this and tell it to only import the primitive number named density. Okay, now we're getting exactly the same result as if we have this. Okay, exactly the same thing. But what we can do now is we can change the position. Now let me add something to the x to the x-axis. Let me split the vector into x, y, and z. Okay, and then let's add value to the x, and let's create the vector again. So float to vector. And let's use that instead of the sampling position. Let's use this new one. And now we have this input. Let's expose that and go up. And let's move the slider. And now it's moving. The data is moving. Let me show the original geometry. Let's go back. Sorry, I've connected the wrong input. Yep, so see now we're moving the teapot in space. We can also, we can modify any axis we want. We can change the position of any of the axes. You can see now we're shifting the data, okay? We're changing where each of this voxel is sampling its position from. And we're adding this offset here. And what we can do is, if you guys remember when I did the noise here, the noise is not breaking these edges, and the reason for that is because we're not telling any voxel to sample from different location. Each voxel is taking its value from its current voxel position, and we're just multiplying the values by a different amount. And if we want to break the edges, we can simply take the position itself and add noise to it. So here, let me create a vector. I'm gonna set it to 3D noise, and let's reduce the amount. And now look at this. We're disturbing the sampling position using this noise. Okay? And that's how you manipulate data in volumes. Now, there is two things you have to remember. If you want to change a value of a current voxel with something new, you can bind import any field and then bind export it using, for example, like the density. If you want to have a voxel disturbed or the position sampled from a different location or transform this, you have to use a volume sample node, and that will tell each voxel to look up its data from a different location. So these are the two main difference. And then these guys are called called fields, and you can give them any name. And generally we're going to be working with density, temperature, and velocity. Those are the three things that we're going to be creating. And now to the next thing, which is the volume types. And if you middle click here, you can see there's this type is called volumes. And with Houdini, there's another type of volumes that has been recently introduced, and that's called VDB volumes. So a VDB volume is much more efficient, memory efficient. It has a lot of new features, and it has an actual vector type for fields. There's fields that are vector type, and with Houdini volume, everything is just scalar, and for volumes, it just uses a 3 scalar. And with VDB, this is much more efficient. So to convert any geometry into a VDB volume, we use a VDB from Polygon node, and you can just plug that in into the node, and by default it's going to try and create an SDF. We're not going to be using SDFs, this distance VDB. We just need a density, and then this is the voxel size, so I'm going to lower that, and you can see we have pretty much the same result here. Now let me convert this into an actual mesh instead of, okay, and that should, yeah, it's not generating the shade there, but I'm not going to worry about that for now. So you can see we have some data, and we can use the same volume BOP with this data. It's exactly the same. And the main difference, if you middle click here, you can see it's called VDB, and then if you hit tab, there's all these options, features that we can, nodes that we can use to manipulate this data and do a lot of cool stuff that hopefully we're going to be exploring. So this is the main feature, the main core of volume manipulation in Houdini in SOPs, and we're going to be using that to create the fields, a variety of inputs for the DOP sims that we're going to be creating. Thank you guys for watching, and see you in the next video. Bye bye.